Good morning, everyone. We're gonna be starting here shortly in just a few seconds. Just so you're aware, this session is being recorded and it's of course it's live. So the one thing that's important to mention is that this is truly your space. So if you have any questions, feel free to type them in the chat or you can just unmute yourself. So this is really an open forum, right? It's for you to discuss or also for us to kind of guide the conversation, but we're gonna be showing this topic today. You can see it here. So it's basically, oh, it's not that one actually. It's, where did I leave it? I'll tell you. It's basically integrating the CMMT servo drives over EtherCAT on a TwinCAT environment. So I guess I'm going to start by showing you what we have here today in terms of hardware. So I'm going to
Sandro,
yeah.
before you start, just for the audience, it's important for you guys to click on the right side, top of your screen on the right side. There's a gallery view, and there's also a speaker view. So if you guys click on speaker view, will be easier. So you can see the screen on the left and Sandro on the right.
Okay, thank you.
One more thing is you guys are more than welcome to answer a question in English, French, or Spanish, and we will try to answer all your questions the best we can.
Perfect, perfect. Thank you, Alejandro. So I just did a spotlight video on my hardware here. So I'm going to show you what I have here today. I think that you can see the hardware right now. So basically, let me start with the actual controller. So this is the controller that I'm using today, and you can see this is a Beckhoff CX9020. And on the left-hand side, what I have is this cable is going to my computer. This is just for TCP/IP communication, so I can program the device. And on the right-hand side, I have an EtherCAT connection. Don't worry about the modules here in the middle. I'm not using any of those at this moment. I'm just using this on the left and this on the right, right? So basically that's it. This is gonna be my controller, right? Now, if we go back here to the hardware, just give me a second so I can line it out there for you. These are the servo drives that we're working with today. So it's the same servo drive. The only difference that you can probably see is that this one has a little HMI there. This one doesn't. But the nice thing about this HMI is I can just remove it and I can put it on the other one, right? So you can just do that and swap it. So this HMI is actually pretty cool. I really like it because it gives you the opportunity to do some quick troubleshooting. It's also awesome for diagnostics and stuff like that. So like, for example, I can turn the motor here. You can see the motor turning here. And I can see on the screen actually the motor turning. This is perfect for whenever I've been in this situation before when you're troubleshooting an axis and you don't know if the motor is turning or not, right? So you can manually move it and you can see on the display if it is moving or not. So that's a little feature there. These two drives are, remember that I told you that on my Beckhoff controller that there was an EtherCAT connection, so this is where it is coming from. And then it goes into this drive, and then with this little cable, I go out and into the next drive. So that's basically my configuration there in terms of hardware, right? The rest of the stuff, it's standard wiring, you know, like the encoder cable, motor cable, and 24 volts and so on. That's it. I'm not gonna do more things there. Let me just approve some other people that are waiting here on the waiting room. So perfect. So let's get to it. The first thing that I'm going to show you, and I'm not going to spend a lot of time on this, is the commissioning portion of the servo drive. This portion is actually pretty easy. The one thing that you do is that you open this software which is called Automation Suite, and it's this one. So Festo Automation Suite. This is the software that we use for commissioning the drives, right? And what you can do is you can scan the network. Right now I'm connected to the two drives, so I can see the two drives there, and it's telling me, oh, you have this drive, and you can see the IP address and so on, right? So I can assign it to my project. You can see it here. I enter that device, and here is where the configuration is at. Of course, as you can imagine, there's a bunch of parameters here. We're not going to focus on specifically which parameters you need to use. Most of the times, you're not going to have to tweak a lot of parameters. You actually have to specify information about your application, you know, like what kind of motor do you have, what kind of axis do you have, what are the stroke limits, also what's in terms of application data, what's the weight or the mass that you have, right? So that's going to help you to tune the motor a little bit better, right? And actually the tuning function, it's embedded in here. So I didn't do anything crazy here. I just added what kind of servo drive I'm using, what kind of motor. In terms of device settings, here you can just see, do I have an external braking resistor? What kind of field bus am I using? Digital I/O and so on. I can tell you that it took me, when I did this, it took me maybe 5 minutes to do it. It's really simple to handle this software. But anyways, I'm not gonna go into the details of this today because we want to focus on what? We want to focus on TwinCAT, right? So I'm going to open TwinCAT, fresh instance of TwinCAT. So here we go. So we have TwinCAT now. This is just open, completely new project. So let's create a new project here. So file, new project. And here it's asking me, okay, what's the name of your project? And here I'm just gonna call it TwinCAT project 1. Let me get this screen out of the way here so you can put it there. TwinCAT project 1. And then I'm gonna say okay. And it's going to create the project, right? Once the project is created, now what I have to do is I have to tell the project, where am I going to be communicating to? Because I have a controller, right? But I need to tell my PC or my project, where is this controller or who is it, right? And how do I do that? There's an option here that says system. So I can double click on system, and here you can see choose target. So it's telling me that, right? Where am I going to be pointing to? So choose target, I click on that. And now what I can do here is I can do a search over Ethernet. Here's a nice thing that I found. When you do this search Ethernet, usually what you will do is you will do a broadcast search. The way that this works is if you have this controller from Beckhoff, brand new out of the box, this comes in DHCP mode. DHCP is something that you're going to see in all of the devices. Actually, your computer has DHCP, your iPhone has DHCP, or your smartphone. Your house network has DHCP. What is DHCP? DHCP is basically a function that says, whoever connects, so you have a master, right? Like a router. Whoever connects to this router, I'm going to assign it an address, an IP address. How does it work? When you come into your house, you walk into your house and you're already there, your phone detects that network of your house, right? Your wireless network. And it says, I want to connect. So now the router at your house says, okay, you can connect. I'm going to give you this address. So let's say 192.168.4.3, right? So now your phone has that address. That's DHCP. It's basically giving or assigning an IP address. That was kind of a side note there, but I think it's important to know what it is. Where was I going with this? Oh, so when you get the Beckhoff PLC, it comes in DHCP normally. So what it is expecting, it is expecting someone to assign an IP address to it. Okay, that's how it works. So there are multiple ways of doing this, but TwinCAT has this nice function where you can do these broadcast search and search for any of the devices that are connected to the network. Right now, it's not going to find any because I already assigned a static IP address. What's the difference between a static and DHCP? DHCP, as I told you, the router the router is assigning the IP address. When you go the static route, I'm telling the router, no, I already have an IP address, right? So I have a static IP address. So in my case, my IP address is 192.168.4.150. This is for the Beckhoff PLC. Now I hit enter or click here, and I can immediately see it. So I'm going to add the route. And while I add the route, I'm going to pause for just 30 seconds or so to see if there are any questions that you might have. Or Alejandro, any comments that you might have.
No, not right now. We can go ahead. I think
Okay.
we need to. We don't have a lot of time, so keep going.
Yeah, perfect. So
If there's any question, we can answer later. Yeah.
yes, that's right. Okay, so here is just asking me, okay, you're gonna add a route. What's the password for this device? By default, on you can even read this on the back of manual. By default, the user is administrator, and the password is number one, and then okay. So that is basically I'm establishing the path for communication. And I say close and then okay. And now TwinCAT is saying, okay, you're going to change to an actual hardware, which is this TwinCAT CE7. So that's the actual controller that I show you at the very beginning. So yes, I want to change that. Awesome. So now I'm where I need to be. You can see here on the top left, I have these two buttons, right? The green button is to put the controller like in run mode, or to start the kernel for TwinCAT. The other one is just to enter into configuration mode. And this is what I need. This is the mode that I need to be in today. So I'm gonna click on that and then config mode, and that's it. So I'm there now. Now, the next thing that I have to do, which is actually a feature that I really like, is I'm going to click on I/O and then devices, and I'm going to right click on that, and I'm gonna click scan. The reason why I really like this feature is because it scans for every EtherCAT device that's on the network, on the EtherCAT network, and it automatically recognizes those devices. So it saves some time instead of you having to add them manually. So I'm gonna do that now. Scan, okay, it's going. There we go. So now it says, I found some things, right? Don't worry too much about device 2 and 4. I just want to add device 1, which is the EtherCAT master. So I'm going to say, okay, add that, and then scan for boxes. So the boxes are the devices that are connected to that EtherCAT master. So I'm going to say, yes, scan those boxes. And now it's going to find all of the different EtherCAT devices that I have. In my case, I also have an EtherCAT IO link module. So I mean, we're not using that today, so it doesn't matter. Okay, so now before I continue with this dialogue here, you can see here on the left, I have my two drives that are connected. You can see them on the right? So on the other camera. So drive 5 and drive 6. So the controller said, okay, yes, I detect that there are two drives there. How do you want to implement them, right? If I was to click OK here, TwinCAT gives you the option of using, I think this stands for
Numeric control.
Numeric control, yeah. So it would be point-to-point control, or CNC would be more if you want to do like interpolated moves, right? If I click OK here, I want you to notice something. I'm going to click OK. So here, under motion, this was added, this NC task, okay? And the thing with this, if I was going this route, is if I add this, I now need a license in TwinCAT, right? Where is this license? Is here under system and then license. And you can see this is the numeric control point-to-point license, and it says that it is missing because I don't have it. I don't have it on my computer. So I wouldn't be able to make this work because I don't have the license. So I will have to purchase a license to make those drives work. So with the Festo drives, you don't have to have that license because there's another way of controlling this. And let me.
One comment here.
Yes.
One comment here, Sandro. It's important that you can still simulate the license if you want to. You can get the 7 days trial license, but when you get a real machine or something that you want to program, definitely you have to pay for this particular license, which is the TF5000. The other thing is, if you click on their motion and NC task, you're going to have to manually configure a bunch of details on, particularly speaking on the axis. You click on their axis, and then if you scroll down on the axis, you're going to see every axis will have a bunch of configurations. So you have to tell what type of encoder you're going to be using, the type of drive, and many other options for acceleration, deceleration, factor limits, and so on. It's a nice feature when you have a fully backup system, but it's very time consuming because you have to have a lot of information by hand, and you have to manually configure all that.
Right.
Now, when you don't have that, then and you use the Festo drives, is automatically pre-configured.
Right. Okay, so yeah, that's a good point. I will. What Alejandro was saying is that I will have to manually be putting putting all of these parameters here, right, for each drive. So right now I have 2 drives. So that's what I will have to do. Now I'm not sure, Alejandro, is it gonna work if I just delete this one from here and I do it the regular way, or do I have to create a new project?
It's better to do a new project because you're
Okay.
gonna unlink the task
Right.
from the drives.
Right. So I'm just gonna create a new
Just
project.
scan a new one. Yeah.
Yeah, and that's don't worry. To the guys that are connected, it's not gonna take long. I'm just gonna do it quickly. Instead of explaining every single step, I'm just gonna do everything quickly here. Choose target, search Ethernet 192.168.150, and then add route, password 1, okay. And then I close this, and then I said okay, and I want to change that to the new target. All of the steps
Now you can
that we
scan.
already did, right?
Yep.
Okay, now I/O devices. I'm gonna scan the devices. Okay, and I just want to add the EtherCAT, scan for boxes, and I'm here. So this is where we were. We don't want to, if we're using these Festo drives in this particular case, we don't want to go this route because I don't have the license, right? So I'm just gonna click cancel. So I click cancel, and my drives are still still imported into the project and everything. You can see them here, right?
Sandro, do you want
So
to check? Sorry to interrupt. Do you want to check if somebody else is waiting?
yeah, no one is waiting.
Is
Usually I
good?
get
Okay.
yeah,
All right.
usually I
Sounds
get
good.
a notification here. But thanks for reminding me. Now, at this point, we already added the axis, and this is what we want to see. As soon as the axes are there, you can see that the actual position, I'm getting some values, right? And that's good because that means that there's communication to the drive. And I can check that with that drive, and I can check that with this drive, the second drive. So that's perfect. That's what we want. Okay, what's the next step here? The next step is that we have to add a PLC program, right? So we right click on PLC, add new item, and then we're gonna say standard PLC project. I'm just gonna leave the untitled one and then add. It's going, it's adding it now. There it goes. So under this project, there's a couple of things that we have to do. First of all, I'm going to add some references that I'm going to be using. So the references are basically the libraries that you're using, right? If you don't have these libraries installed, you can download them from the Festo website. You can click on here, library repository. Once you download them, you can install it here, okay? If you already have them installed, like in my case, you will only, instead of going to the library repository, you would only go to add library, and then application, Festo, common, and then you will see the libraries there. You have to add all of these libraries here. It's very important that you add them all, right? So I'm gonna add them quickly here. That first one is the one that takes a little longer. But if you don't add them all, you might have some problems later on because there's actually a relationship between the libraries. So it's very important that you add them all. That's what I'm gonna do here. CIA 402, add the next library, Festo, common.
And those are free of charge libraries for sure, standard libraries that you can download from our Festo website. In fact, if you download the package that comes with it, it comes already with a sample code in case you want to just go through and also the documentation is part of the package, which is nice and easy.
Right. Yeah. So now my libraries are here, and if I wanted to see what's inside of those libraries, I can click here and I can see the function blocks that are there, right? Okay, perfect. That's the library there. Now, the next thing that I have to do is I'm going to create a global variable list just so I can make some declarations. So I'm gonna add the, oh, no. Right-click GVL, add, and then global variable list. And I'm gonna click open. That's it. So just gonna comment that first thing. Here, I'm going to declare one axis for now. X underscore axis underscore CMMT AS. CMMT, yeah, just CMMT. And then this is going to be of type something, right? Now, what kind of type is this gonna be of? right click on it, and then input assistant. I usually use the shortcuts, but I wanted to show you which one. Input assistant, and then you're gonna go into structure types, open here, open this a little bit more, and then you're gonna go into this one, this library here, and then you're gonna look for this one that's here. Be sure not to add any of the other ones. You gotta use this one right here, okay? So click on that, and then I just add a semicolon there at the end, and that's it. That's how I declared my first axis. Now, one thing, you're gonna see here, I'm gonna declare a second axis here as well. It's gonna be y-axis instead, okay? Let me just make sure that I'm following the same convention that I wanted to use here. Give me a second. CMMT AS actually. Okay, CMMT underscore AS underscore AS. So I added those and I have those axes there. Now on the main program, I'm gonna call those axes. So it's X axis. Oh, something that I usually do here that I recommend people to do is go to Tools, Options, and then TwinCAT, and then PLC environment, smart coding, and then list components immediately when typing, because it saves me time. Instead of going to look for the variable, it's already there, right? So here I'm just gonna initialize that variable or call it, right, like that. And that's how I'm calling those two variables. Now, at this point, I want you to look at something. I have not compiled my project, right? You can see, well, actually, you notice I have not compiled my project. Once I compile it, some I/O is going to be generated here, okay? So I'm going to compile it now, build, and then build solution.
We have 8 minutes.
Yeah,
Sandro.
okay. I'll hurry up here. I'm just going to show this. Okay. And I'm just going to show this part because this is critical, right? Now that I compiled, you see that I have some inputs and outputs here, right? These inputs and outputs are the ones that are in my program. So you can see these come from that global variable list that I created earlier. So GVL, x-axis, blah, blah, blah. I have to link these variables to the actual EtherCAT variables that are coming through EtherCAT, right? So how do you do that? Just click on here and then link to, and you look for that drive. In my case, x-axis, this one, it's gonna be drive 5. So WC state, and I look for drive 5, WC state, okay. And you can see that the link was created, okay? So you're gonna do that for all of these different variables that you have here. And I was telling this to Alejandro, make sure that you don't forget to do this ones, the outputs as well. It's very critical. I'm going to open another project that I already have that I was working on, so I can show you how a finalized project would look like. So where were we? We were, let me just close all.
In case anybody wants to have a copy of this project, we can definitely send it to you. Otherwise, from our website, you can download it and it's already pre-mapped and pre-configured.
Yes.
We're just showing the step-by-step, but normally you don't have to go through all this because, as I said, it's pre-configured.
Right.
If anybody has any questions in Spanish, French, or English, you guys are more than welcome to ask. You can also wait until the end of the presentation, or send us an email, or send us a quick message on LinkedIn.
There's a question there. Will the process be the same for the CMMT ST? And the answer is yes. It's exactly the same process, same function blocks, nothing changes. Yep. So that's a great question, actually. Okay, so here, this is the other project that I opened. All of the variables are already linked because I went through this process that I just showed you, so we don't have to worry about that at this point. And what I did here is, on main, you see that I called those two things. I also created 2 additional programs here under main, and I'm calling those 2 programs and also the sequence program. Now, here, what you do is that you add the function blocks that you're going to be using. How do you add those function blocks? You go to Toolbox, and then you add a box, and then you call here the function block that you want to use. For example, I don't know, Power Festo, right? You double-click on that.
one of the things important here is we're using a standard PLC open blocks,
Right.
but they are slightly modified for the Festo drives. But the structure and the same is the same way that we normally call an MC power, MC home, MC reset, and so on. We just
Yeah.
call the Festo because we added also visualizations that are completely different, so we can have more information as part of the visualization. You can show that also, Sandra, there.
Yeah. This is a visualization that Alejandro is talking about. Can you also use method calls opposed to function blocks?
Yes, you can.
Yeah. Yeah, you can.
Yeah, you can definitely You can definitely do it.
Yeah.
In fact, this is working exactly the same way that any other function block is for back off. So it works exactly the same way.
Yeah. Okay, so here you will add all of the function blocks that you need. You can do it in CFC or you can do it in structured text, whatever you prefer. And then that's about it, really. I'm going to log in and actually run this code so I can show you how it works. So it is being transmitted now.
One of the nice thing about this to mention, Sandro, is our software is also codices based for our own controller. So using methods, calls, and any other structured text or any other advanced programming methods that you can use in TwinCAT is also used for the Festo controller. So they are 100% compatible in terms of coding.
Right. Actually, I downloaded the. Okay, I'm downloading this project now, the one that I have here. So log in, and now you can see that there's something going on here, right? So my first axis is enabled right now. You can see here, right? This is the visualization. So if I wanted, I could also execute, for example, I don't know, a home. I can execute this, for example, this one, and I could also execute a move absolute. For example, I'm gonna move this. Which one is this? The x-axis. So it's the one on the bottom on the video that you have on the other camera. I'm gonna move it to 360 degrees. I'm gonna set a velocity of 36 degrees per second, an acceleration of 5,000 degrees per second squared, deceleration of 5,000 degrees per second squared, and then execute. And now you see the drive on the bottom there moving, and it's gonna do a full turn at 360. And you can also see the position here, the live position, right?
Yeah, at this point, you can also link all those tags for your own variables, or you can reutilize this.
There's another question
here.
Yeah. Is there a TwinCAT runtime we can use on our PC to connect to Festo Drive via EtherCAT if we do not have the actual backup hardware with us? Yes.
Yes.
Yes, you can just use your PC as an EtherCAT master and control the drives if you wanted to.
Yeah, the way that backup does is when you install TwinCAT, your computer becomes an EtherCAT master because you install the kernel inside, so you can run pretty much everything that you can run on a standard backup PC in your own computer, as long as you have administrator rights and you don't have any particular like weird Ethernet card, because normally backup is very restrictive in terms of what type of hardware you want to use, but still it's pretty much a standard for in the market.
Right.
One of the things good. Sorry, Sandro, to interrupt you. In the function block, something that is important for everybody in the audience is the homing method. So go to the screen and show the homing function block on the visualization, sorry.
On the visualization, yeah.
Yeah, and zoom in on the home. So one of the nice things about this is if you have already experience with homing methods in the standard TwinCAT and backup drives or any other, you have probably a big time trying to get a home properly implemented. In this case, is super easy. The way that the home works is
it's actually right
easy
here
because it's a one function block, and you can just tell what type of sensor you want to use. If you want to use a hardwire or you want to use a block or anything else, you execute it and you're done. So you don't have to worry about programming particular sequences and waiting for signals to come back to the PC and stop the drive and so on. That's one of the nice things about this function block.
Yeah,
yeah, go ahead.
That's a great point. You can see here that we're just executing the home. We just execute that home function block, and it goes and it does it, right? We have just like 30 seconds left. So what I'm going to do here, this is a code, and how many lines are here? 138. It's a very short code that it's running 22 different positions for those two motors. So I'm going to run this code now so you can see what it does, and it's just basically be turning those motors. It's going to be doing a movement, right? So you can see both motors are turning. I turn to another position, right? And it keeps going. Every time that I toggle this bit, imagine that this is just a button, right? So every time that I turn on this bit, the motors turn. So you can see it's super, super easy to make this implementation. I mean, in less than 150 lines of code, you can easily do it. And this code is actually for 3 drives, right? So if it was just 1 drive, it will be less lines. So that's it for today. I think we're planning, maybe we still don't know, but
there's one more question actually.
Yeah.
It has happened to me with EtherCAT master PLCs. When I enable them, I usually get a stop category error. Do you know why? And I have to reset with the MC reset block. In fact, we have a function block here that is exactly the same, the reset block, but the stop category is really the way how you manage to start your drives. So if you look at the code, and actually, Sandro, you're gonna scroll up and show how you do it, how you implemented the enable of the axis. And you can quickly see it. It's basically what we normally do in this case is we reset, we wait until the reset is done, we enable the drive, we wait until we enable the drive, and by using the axis status, we can continue the process. So in this case, these function blocks allow you to do way more manipulation and also give you more information from the visualization. Actually, you don't have to go directly into the code. You can directly pull the information from.
Right. This is why this visualization really comes in handy. I guess there's another comment there.
Yeah. Can you manipulate values like following error settings made in automation suite via the PLC? Yes, you can do it. In fact, if you go and if you find the particular
parameter
code
ID
that you want to access, then you can definitely access from the EtherCAT interface.
Yes.
In fact, you can. Yeah, go ahead.
I was going to say that what Alejandro is saying is that all of these parameters that are here in Automation Suite, if you hover over this, you can see there, it says P1.1150. That's the parameter ID. So you can actually access most of these parameters and change them on the fly. We've had some applications before where, for example, for a flying saw, you can change those parameters online, so it can be done. I know that there might be another comment, but I just wanted to mention this before we go. Stay tuned. I think that for the next session, we might have a guest. We're still planning on it. And also make sure to drop us a comment on LinkedIn if you are interested in a particular topic that you want to discuss. Okay. So Alejandro, I don't know if you have any other closing remarks.
No, I think pretty much. Thanks for everybody to be in this call. If you want to stay and you want to stay for a little bit longer and the Zoom drop you off, then you can reconnect and we can continue the chat. The problem is we're using the Zoom, so it will kick you out after some time, but we're going to stay here for a little bit longer.
Yeah.
So in case you have more questions, you want us to continue, we're going to stay for almost 20 minutes more after the Zoom finish. So we're going to reconnect to the same invitation.
Right.
Other than that, it's pretty good. I like the idea of having all these people connected. Thanks for having us. And if you have any comment, as Sandro mentioned, please send us a quick email or over LinkedIn, and then we'll be more happy to help you guys.
All right, perfect.
Yeah.
Yeah.
Go ahead.
I guess we have to. We're saying send us an email, but they might not know what our email addresses are. So my email address is sandroquintero@festo.com, and Alejandro's is alejandro.lopez at festo.com. So you can always reach out to us on those email addresses or on LinkedIn. You can just drop a comment, give it a like, and we're really looking forward on preparing more topics. It doesn't matter if it's not a control topic. We also have some mechanical guys.
How many minutes do we have? How many minutes do we have? Is almost done?
No, we're overtime. So this is
Oh,
overtime.
that's nice.
If people are here, they're because they want to. Yeah,
Okay.
you can just go offline now. But
Yeah,
I was gonna say, Alejandro,
yeah, go
we
ahead.
also have mechanical guys. So if you have
Yeah.
a mechanical topic, we can also do a mechanical topic. Okay. So yeah.
Yeah.
Go ahead, Alejandro.
No, one more thing is, acuérdense que todas las personas están invitadas si hablan algún otro idioma y nos quieren realizar algún comentario o hacernos algunas indicaciones, alguna pregunta, también estamos disponibles. Muchas veces en alguno de estos chats podemos conversar y explicarles algo más. Pour tout le monde qui parle français, on est prêt à répondre à vos questions. Si jamais vous avez d'autres commentaires ou vous avez des questions, vous êtes bienvenus à nous envoyer un petit courriel à alejandro.lopez@festo.com ou bien nous envoyer à sandro.quintero@festo.com. On est prêt pour vous aider ou bien vous supporter. Okay,
Awesome.
that's it. I think, yeah, we're gonna stay for a little bit longer. If
Yeah.
anybody has any question or comment,
Yeah.
otherwise, let's give it a try. Let's run the sequence.
Yeah, I guess what I'm gonna do here, well, if we can you monitor the chat in case they have any specific questions?
Yeah, I'm gonna be here.
What I'm gonna do is I'm just gonna go through the sequence and explain what's going on, in case in case no one has done this before. So what we're doing here is we have a case statement. The way that this case statement works, it's checking for this variable, what's the step, right? Like what's the number on that variable. And the way that it works is that this variable is initialized with a value of 100. So once it is initialized, it goes into this portion here, right? And you can see at the very end of that case statement, it says, now here, this variable, change it to 110. What happens in a case statement is that now with 110, it goes to the next step. So I actually love using case statements for doing sequences, right? Because now you can go step by step. And it's also pretty helpful for doing troubleshooting because now you can also know where did the machine stop. So anyways, let's go through these steps, and it shouldn't take us long. This first step, what we're doing is we're setting everything to off, or making everything false. So you can see we're doing the home for the X and Y, we're making it false. The execute, home, execute, false. Power, enable, false. Reset, execute, false. So we're just resetting everything because this is the very first step, right? Now we're checking here. If this done bit is false, and this done bit is false for the y-axis, then go into the reset and now make it true. So now reset any faults or any errors that might be on the drives, just clear them, okay? So now it jumps into the next step, which is 110 by doing this here, right? So 110, now it says x-axis reset. If this reset that I did here, is it done? And the other axis is done as well, then make that reset, this execute, make it false, right? And then jump to the next step. That's it. It's just very simple to follow this kind of code. So now here we have a B wait. So this is just a timer that was implemented here. We're setting it to false. So B wait, and we are assigning it with this symbol here. We're assigning it a false. And then we say, okay, now enable. So power, enable both drives. So make this true, make this true. And now we say, yes.
Sorry, let me pause for a second. The wait here is actually depending on the mechanical system. Sometimes you need to give some time, a little bit extra time to the axis to react. Can be because mechanically you need more time to get the motors properly ready, and that's why sometimes you get errors or you get following errors if you try to enable and automatically move the axis or try to home. So we want to give some extra time in case some reactions are required.
Right. Okay. Yeah, that's a good point. It will be considered maybe like a settling time, right?
Yeah.
So where were we? Okay, here.
Yep.
So we enable both drives. So power, enable, true. So we make it true. And then we check, okay, I told you to enable. Are you enabled? Oh, sorry, here. Powers, what's the status? Are you enabled? Excuse me. If it says yes, this one and this one are enabled, then make this wait true and then jump to the next step. Now, this is the timer, right? So once we enter,
That's the one.
once we enter into the timer, we say wait for an X amount of time here, wait for 1 second, and once you wait for 1 second, then once that second has passed, then enter this if statement and then execute a home, right? So now it's gonna go to home. And of course, I mean, remember that this sequence really depends on your mechanics, right? Because you might need a confirmation from, I don't know, another section of the machine that, let's say, a pick and place, it's out of the way, or some pneumatic actuators are out of the way, you're not going to hit anything. This is something that you have to implement depending on your logic, right? But this is just to show you an example.
Nice thing about this also, Sandro, is if you want multiple axes, you can just copy paste and replace, and you can add as many axes as you want. So you can actually create, if you look at the left, the X axis control and Y axis control, you can just copy paste those, or you can actually, if you are more expert in terms of coding, then you can create multiple instances, which is the way that we normally do. In this case, we wanted to make it simpler also for and understandable. So you can copy paste these, and then you can add as many axes as you want.
Right, correct. So here we're just basically executing the home. So we say home, execute true, and now both axes are gonna home. Here we ask it on the next step, on 140, we ask it, hey, are you busy? So are you executing the home? And if it says, yes, I'm busy, then, and you're not done, then jump to the next step. Once you're done homing the axis for X and Y, then execute a false, or make it false, make the execute false, right, for homing.
Let me pause for a second. Same thing that we just discussed earlier. If you do the same sequencing in the standard backoff way, which you require to have an external sensor to catch the flag, or maybe monitor the torque on the motor if you want to home against a mechanical stop, then the program becomes really complex and actually very, very intimidating when you want to take a look. So in this case, it's really simple. You send it to home, wait for the home be done, and you're done. The configuration for the homing is actually, you can select what type of homing you want to use, or you can choose the one that Automation Suite was pre-configured. And that is, under the axis, you can see we have a current position, but if you go back to the TwinCAT for a second and go to the visualization.
Here, and go to the visualization.
Yeah, visualization, and you're gonna see there. So the homing, if you go online, you're gonna see the homing method. So which method you want to use as parameterized in our Automation Suite, or you can select any type of the homing method that are available from PLC Open Structure.
Yeah, this is according to the CIA 402 standard, I guess.
Yeah, exactly.
I usually prefer to use the Automation Suite because the Automation Suite method, because this might be more confusing, right? For someone that's not experienced with CIA 402, they go into here and then they suddenly see, oh, this is homing via method 23. What does that mean, right? And instead of doing that, you can just, oh, sorry, not that. You can just go in here, and now it makes a little bit more sense, right? You're like, oh, okay, that's the number that they're talking about.
Yep.
Okay, perfect. So let's just finish with this sequence. We were on the homing topic. Now we enter now the step 160, and this is just a bit to start the execution of the motion, and that's just a bit that we're using for simulation, right? Or that I can manually toggle it here in software. But this could also be like a push button, or a portion on your sequence. Like, let's say that you have a conveyor, the work piece arrived at the right step on the process, and now you want to start the axis, right? So this is what you will have there. So if this is true, then go to the step 170. And this step right here, this two right here, this is where all of the motion happens. So this is actually a pretty nice way of approaching these different movements. You can see up here that what we did here is we declared an array of 22 positions, and we used that array to assign 22 different positions for the x-axis and 22 different positions for the y-axis. So that's a pretty effective way of doing this. And what we're doing here is we're basically saying reset, so move absolute execute false because we don't want it to move yet. And now we say if the position to move is less than 22, so we're checking the limits of this array, and we're saying this is just a counter, right? So we're incrementing every time that we complete a movement. So if it is less than 22, then assign these values. And basically
Yeah.
what we do is assign the different positions that we have in the array.
If I can mention something here, imagine is a recipe, and then the deep pose move is basically recipes. So recipe 1, recipe 2, or any kind of adjustability you want to have on your machine, then you can select recipe 1, 2, 3 from the screen, and it will automatically pull the information from the array, and that's it.
Yeah, it would be something like doing this: velocity,
Like a
acceleration,
basic table.
deceleration, and then I would say
The
position 1,
index.
yeah, or index, yeah, let's call it index.
Mhm.
Index 1 and index 2. So we will do this 22 times, right?
Yeah, we're basically playing with those numbers, but it can be done with standard coding for
Right.
recipe management.
Yeah,
It's a very
exactly. So
simple way to broadcast information through different drives.
yeah. So this is what you will have. You will have these 22 different positions that you can go to, and now you can call it. You can specify here. I want to go to position 150 with a velocity of 5,000, and same for acceleration and deceleration. And all of these values can be different, and you can also change them on the fly if you wanted to, or readjust them. Anyways, so that's what we're doing here. We're just defining the velocity of both axes, then defining the acceleration and deceleration, the jerk as well. And here we're assigning the position. And every time that we complete a cycle, we just add a number to the counter, and that's how we are moving to different positions every time. Once all of this assignment is done, then what we do is we just execute the move absolute. So you see here, move absolute, execute, we make it true, and now the axis moves. I mean, if not, there's no fault or anything like that. If the axis moves, it'll say it is busy, and once it is done executing that move, it's gonna give you a done signal right here. Once you have that done signal, you know that the axis has finished moving. Remember that these are point-to-point movements. So those two motors that I have there on the other camera are not moving are on synchronized motion, actually, right? They're moving independently between each other. So imagine that I could have an X and Y axis, sorry, X and Y axis. So it would be moving on X and moving on Y independently, right? Or I could have just two axes in parallel if I wanted to.
Yeah, one more thing on that regards, Sandro, is if you ever want to use definitely a synchronized motion, you're gonna still use our Festo EtherCAT drive because they compile with the standard PLC open instructor and everything related to EtherCAT. So as long as in this case for backup you pay the license for additional motion, then you can do synchronized motion. And we just have to configure the drives slightly different in order to do that additional motion. But everything else works the same way under backup.
Right, right. Yeah, and that's about it. We just reached the step number 200. We're checking if both axes were done. We make the move absolute execute false, and we add here. This is the counter that I was talking about. We just add a new another number to that counter, so we now restart the whole cycle and we move to the next position. Whew. So that was a sequence code explained in 5 minutes or so.
If
Yeah.
you want to go and check in the visualization for a second, I just
Mm-hmm.
wanted to see if you have the function block there. Do you have the force, the actual force?
Yes, I do. It should
Okay.
be somewhere here.
It's
Give
on
me.
the right side, I think.
Yeah.
So one more thing in here is, as part of the function blocks that we have all the type of standard motion, like read actual velocity, read actual torque, halt, stop, jog, move additive, move relative, and move absolute. The nice thing about this is you don't have to worry about configuring many other things. So you just link the block to the axis ref, and then you're done. You pretty much have control on everything. And the values are, that's important. The values are engineering values. So you don't have to worry about calculating like counts, conversion, and so on. You just get the values in millimeters or whatever you configured in your automation suite. The force is a continuous force, and you can read it all the time if you want, and then it will give you the possibility to control the torque too. So you can move in torque control.
You mean you want this one,
So
right?
far?
Read actual torque. This is the one.
Yeah, that one. Yeah,
Okay.
yeah. Read actual torque. Yeah. Yeah, I think that's it. I think pretty much you covered everything.
Yeah.
Any question, guys? So far, we're gonna be ending up soon.
Yeah,
That's
I think
nice. We got some extra time on Zoom. I think
yeah.
because people connected, right? So that's nice.
Right.
The more
Right.
people connect, then the better will be, right? You get extra time.
Exactly. So yeah,
All
I mean,
right.
we don't want to overwhelm you with information. So that's gonna
Yeah.
be it that we're gonna be covering today. And again, this is gonna be like a commercial, but again, propose any topics that you want to hear. Electronic control, mechanical topics, programming, vision, servo drives, pneumatics, even if you want to. Sensors.
And
There's multiple topics in terms of automation.
right.
So networking also. Yeah.
Okay, we'll see you guys in a couple of weeks. So that's gonna be what's the date for the next session actually?
The
Let me see.
date
Oh,
for
the 25th,
the
the June
25th.
25th. That's gonna be.
Yeah. June
Yeah,
25th. Yeah.
we're gonna upload the webinar in a YouTube channel, and then we'll let you guys know. We'll send you guys a link. If you want to shoot us an email or just stay tuned on LinkedIn, then we can send you a copy of these files.
Yep. All right, guys, that was it. Thank you
All
very
right.
much for your time, and
Thanks to
we'll
everybody.
be talking to you.
Gracias a todos por conectarse. Merci tout le monde. On se voit dans 2 semaines, juin 25. Nos vemos en junio 25 cuando
Junio
tengan
25.
un ratico. Listo, media horita y nos conectamos, ¿vale?
Sí, misma hora, mismo
Sandro.
canal.
Listo, Sandro, nos hablamos.
Thank you, Hardus, for joining from South Africa.
Yeah, that was a great audience. All right, thank you.
Thank you. Bye-bye.
Okay, guys, bye.